Okay, shall we start? Are you able to hear my voice, guys?
Yes, sir.
Okay. So question paper pattern. So question paper pattern is very simple. There would be no A or B questions. So only one question would be there. So for example, 1, 2, 3, 4, 5, and 6. So totally there are 6 questions you need to attempt. You have it for 50 marks, right? The total maximum marks is 50. Am I right?
Yes, sir.
Okay. So the first 2 questions would be of a spur gear. Second 2 questions would be of a helical gear. And the next 2 questions would be of a worm gear. Okay. So these questions will carry 17 marks, 17 marks, 17, 17, 16, and 16. So out of these 2, you have to choose 1 for 17. Out of these 2, you have to choose 1 for 17. Out of these 2, you have to choose 16 for 17, so that your total marks would be 50. Is that fine? So you can choose one of the questions in spur or in the spur. One question you can choose from the spur, one question you can choose from the helical, and one question you can choose from the worm. So this is the pattern. Is it clear? Any doubts? Any doubts? Okay. So score well, do well, prepare well, don't just copy. Okay. If you do it, if you do copy, what happens, you may get the marks for the internals, but definitely it affects a lot when you're writing your external examination. So take it seriously. Few subjects like design and HT, just learn the concepts and try to write. Okay, don't just write copying it. Okay, because it will definitely help in your external examinations. Okay, shall we start the new topic today? Are we ready? So everyone is having the data handbook, and let me have a count. How many of you don't have your data handbook physically with you? 1, 2, 3, 4. Only 4? Okay. Okay. So is the delivery service available at your location so that you can order one more? It would be really helpful, man. No delivery. Why, man? Flipkart and Amazon is being delivering everywhere. Already we have one. Okay. Acha. Okay. So you can do it anyhow. I have sent it in your Google Classroom, the soft copy, but it becomes a little bit tedious. If you have a book, it's a lot more comfortable to just scan the pages very fast. But if you have a PDF, then what have you planned for your examination? How are you going to do that? So will you use a soft copy? Because I'm damn sure your examination would be of 1 hour 30 minutes, I guess, right? Correct? 90 minutes examination. Am I right? No other choice. Okay. Okay. So in that 1 hour 30 minutes, so you have every 30 minutes for a problem. Okay. In 30 minutes, you have to solve for spur. In the next 30 minutes, you have to finish helical. And in next 30 minutes, you have to go for worm. So plan accordingly. Okay. So have a good practice. Okay, and plan accordingly so that you can use your soft copy. Okay. So make sure you stick on to this particular timings. For every 30 minutes, you have to finish a problem. Okay. Now, shall we start the new unit, which is the module number 1, which we were supposed to start at first, just
The
because the
theory will
gas.
not come.
Huh? Yes.
Theory will not come.
I did not get the question.
Theory will not come, sir.
Only formative number of teeth you just study. I'm even not sure that would appear in your examination. It may or it may not. Okay. So do not, my suggestion is do not concentrate much on the theory. The problems you have to concentrate. There is only problems in the design, man. There is very limited theory. There is no concept of theory in case of design. Okay. Shall we start? Any other doubts? If you have, let me discuss before I start the new module. Any doubts? No. Okay, shall we start?
Yes, sir.
So all of you just open this 14th chapter in your data handbook, which guides us about the flexible machine elements, which are commonly known as belts. Okay. So we were supposed to start this particular module at the first, since we found the gears as an easier thing than this, and it has a continuation from spur to helical, helical to worm. We have sticked on to that and completed the gears, and we came back to module 1 once again. Okay, so this particular thing comes under the module 1. So module 1 consists of 2 parts. The first one is springs, and second one is the belts. So both are huge in content. Both are huge. That's why we are not focusing on springs, but we are focusing heavily on belts, and we are learning each and every aspects of belts. Okay, and it is easier. Belts is easier when compared to the springs. Is that fine? Now, shall we start the module? All of you just write your heading in your notes. The belts, module number 1, belts. Okay. Now, in your data handbook, the information regarding the belts is given in the chapter number 14, which is indicated as flexible machine elements. Okay. Just have a look there. So let us have a just brief discussion why this belts concepts have come. So you already have a gear, isn't it? You already have a different types of gear. You have spur, you have helical, you have bevel, you have worm. Different types of gear systems are available in order to transmit the power from one shaft to the other shaft. Okay, so in order to transmit the power from one shaft to another shaft, you already had a gear system. Then why you require a belt? Why you require a belt? Because already there was a gear system. You can use the gear for it. No. What is the need of a belt?
No wear and tear.
No wear and tear. Okay, can be considered material to material rub agodilla. So one tooth is there like this. Suppose another tooth is there like this. Okay, so material to material wear agodilla. So as in case of a spur gear or a helical gear, there is a material to material wear. So here, two different pulleys are there upon which you are engulfing a belt onto it, so that there is no material wear. Rather, there are other problems like slip and twinning. Okay, next. Longer distance transmission of power, and that is the main reason why we are opting for a belt. Suppose if the points are closer, if the center distance between these two power transmission are closer, you can use a gear which is very convenient and lot more efficient than belt. I'm saying you gears are lot more efficient than belts. Belts have very less efficiency. It has a slip in it. Slip in the sense the belt will slip on the pulley. Okay, so whenever it is transmitting, no, while the power is transmitting, what happens is your belt will move, but your pulley will try to pull it up. Your pulley will try to pull it up, but it slips. So that slip factor is also there in case of a belt. The efficiency is also less, but why we are using it? Look at the center distance. So for the huge center distance, you can use the belt to transmit the power. So if you want to use the same for the same center distance, if you want to use the gears, what happens? What could be just imagine what could be the size of a gear if you try to manufacture like this. Okay, it occupies a huge lot of space if the center distance is larger. So if the center distance is larger, so automatically we will go with belt drive system. Is that clear? What do you mean by belt drive system and what is its importance? Any doubts? If you want to discuss any other points, you can discuss. Are the things clear?
Yes, sir.
Okay. Now, all of you just open your data handbook. What is this page number, man? 289 page number. Okay. Just go through each and every aspects starting from here, page number 239, 289, 290. Okay. Just see what all different parameters you have there. Look into the formulas, how they are. First, look into this. What different formulas are there? What are the different formulas are there? Just check. Just have a check in your data handbook. What are the different types are available? 292 is enough. 293 up to 294 you can do it. Okay, 295 is rarely used. Okay, we'll use it. 295, 296. So up to here, up to this particular point. Okay, so you don't have a rope system. So rope system was there for earlier syllabus. Really, I'm telling you, your syllabus is condensed like anything. It is shortened. There is no cylinder and cylinder heads. There is no curved beams. There is no rope design, no chain design. Very much condensed. Okay. So you are very much lucky enough to have this particular syllabus with you. Okay. So up till here, you can have just a look of all the formulas, whatever you have. Just have a look. Just get to know the notations first. What are the different notations? Get to know the notations first. Okay, for example, net area of the wire in a rope. What do you mean by A in the sense? Suppose, think there is a pulley like this. Okay, upon this pulley, there would be a belt which will be wrapped, isn't it? So this is the belt which will be wrapped. So if I cut it at this edge, and if I look, whatever the cross section would appear something like this, right? So this particular cross section is of the flat belt drive. So this is a flat belt drive, and whatever the area is there, that is indicated as capital A. Is that clear? What do you mean by area of a wire in a rope? Okay. B is nothing but width of the belt. Width of the belt is nothing but this. This is the width of the belt, capital B. Okay. This is small b. Capital B is the width of the pulley. Suppose the pulley is something like this. Okay. This is the pulley which is rotating. Now, capital B is the width of the pulley face. and small b is this particular length. Are you able to understand? Getting it? What are the different parameters there? Getting it? Just see that center distance between the pulley. This you can understand. If there is one pulley here, another pulley here. So what is the center distance between these two? It is known as capital C. Small d and capital D are the diameters of smaller and larger pulley. So this is of the equal diameter. What are the figure I have drawn? So what happens generally is it will be something like this, right? A larger pulley and a smaller pulley. So diameter of the smaller pulley is taken as capital D, and diameter of the larger pulley is taken as capital D, and the smaller pulley is taken as small d. Okay, acceleration due to gravity, net belt pull. So whatever the pull you are able to experience, the tension in the belt, that is given as Ft, and the tensions in the tight slide and slack side respectively. Let me explain this. Okay, now if I zoom it in like this, see, if this is a belt, no, okay, now all of you just try to understand and visualize the content what I say, please. This is very important to understand the tensions of the belt. Okay, okay, fine. Now, so this is the belt which I have drawn. So what I do is I connect a motor to this. I connect a motor so that this particular thing would rotate clockwise like this. So what happens? The top edge, which is this, will be pulling it continuously like this. It would be pulling it continuously. Yes or no? This will be pulling it continuously. So this is side 1, I would say. This is side 1, and this is side 2. Side 1 and side 2. So in the side 1, what happens? It will be having a continuous pulling action like this. This particular pulley will be pulling continuously. On the side 2, what happens? On the other hand, on the opposite side of it, it would be leaving the belt. Okay, the pulley would be pushing the belt. It would be pushing the belt like this. Here, it would be grabbing it like anything. Here, it would be pulling the belt like anything. Understanding the point? Now, according to you, if I talk about the tension in the belt, on which side the tension would be more? Whether the tension would be more on the side 1 or whether the tension would be more on the side 2, according to you. Have a visualization of it. On which side? Yes, exactly. Very good, Kev. On which side the tension would be more? Whether it is on the side 1 or whether it is on the side 2. Side 1, isn't it? Good. So you have to imagine the things, how exactly it looks like. Good. Very good. So that's why this particular thing is known as a tight side. And the tension in this particular side is known as T1. And other side is known as a slack side. That means this particular side, this particular side of the belt would be wobbling like this. It would be wobbling. If you have seen the belt, that you will have a clear imagination of things. Okay, this side would be wobbling, but this side would be very much straight enough because it would be pulling. No, there will be a maximum tension in this, so it would be very much straight. And this would be wobbling to one certain extent. It would be wobbling to one certain extent like this. Okay. Now, that's why this is called as slack side. And the tension here, it is known as the T2. Is that fine? Any doubts here? What do you mean by tight side? What do you mean by slack side? Any doubts?
No, sir.
Yes, Amir.
No doubt, sir.
No doubts. Okay, fine. So now, again, the same concept. The one would be driving. So I would be taking this as 1 and this as 2. Now, which one is driver and which one is driven here? So which one is a driver and which one is driven? what is driving what? Whether one is driving two or whether two is driving one.
Two is driving
to
one,
one.
sir.
Two is driving one, isn't
One,
it?
sir.
So that also is there. Driver and driven concept is also there in case of belts, as in case of the gear system also. So the velocity of the belt, again, it is pi dn by 60 min, which you have used in your gears. The velocity of belt, that is the linear velocity of belt. Mu is the coefficient of friction between the belt and the pulley. So there would be some friction arrangement, isn't it? The friction arrangement would be there. So that is known as mu, coefficient of friction. And one more thing, there is something known as the angle of wrap. What I am talking about is, now I talk about angle of wrap. What is this angle of wrap? Let us see. Okay. Suppose now, for this smaller pulley, so this is the center distance, correct? Now, mark the points where the belt is touching the pulley. So it starts from here, okay, continuously it is touching, and it leaves the belt here, correct? It leaves the belt here. Now, if I try to measure the angle between these two, okay, so this particular thing is known as angle of wrap of smaller pulley, since it is a smaller pulley here. Getting my point? All of you understood what do you mean by angle of wrap? Yes. Now come to the larger side. Same concept. So this is a bigger pulley. Okay. This is a center. From center, where it is touching, here it is touching. It is engaging. So it is next. It is wrapping like this. Wrapping, and at this particular point, it is leaving the pulley. The belt is leaving the pulley. Now, if I just connect these and measure the angle, this angle and this particular angle is known as the angle of wrap of a larger pulley. Got it? So this is nothing but angle of wrap when you apply for a smaller pulley, and the angle of wrap you apply for a larger pulley, and that is known as theta. Yes, or theta L. So angle of wrap is also considered as the arc of contact. Even it is called as arc of contact. It has several names though, but you will call maximum times angle of wrap or arc of contact. Okay, thickness of the belt is nothing but this. This is the thickness of the belt. Is that fine? So this is the thickness of the belt. So if there are any other formulas, we will get to know. And there is centrifugal tension also. So since this is rotating, no, there will be one more tension which is coming across because of the centrifugal rotating action, that is known as TC. This particular thing is known as the centrifugal tension. So this particular centrifugal tension has to be taken into account only when the velocity is maximum. When the velocity is very less, centrifugal force will not act, isn't it? Centrifugal force acts only when there is good number of velocity, highest number of velocity, only then the centrifugal tension would be acting. Then only you have to consider it. And when to consider it, when not to consider it, we will discuss once we start the problems on it. Okay. Now, any other doubts in these parameters? So sigma D is a allowable stress. Same thing for the belt material. For the belt material, sigma D is an allowable stress. Sigma C is centrifugal coefficient of leather belts. We'll come to know once the problems is being started, once you start to use it. If any other parameters, if it is new to you, definitely you'll come to know while you are starting the problems of it. Okay, is that fine? Shall we start a problem? Yes or no?
Yes, sir.
Okay, now take this particular problem. Please copy it. Okay, we'll just try to solve this particular problem today. try to draw a diagram also. So again, there are two types of belts. I told you, I forgot to tell you. The first one is known as a flat belt, and second type is known as a V belt. V belt would be something of this kind. Okay, so all this belt. Something like this. Okay, V belt. So the flat belt would be flat enough, would be very much flat enough like this. So this is the flat belt. Okay. Hope you got the imagination, isn't it? The cross section. If you observe the cross section like this, so look at the cross section. It is of a trapezoidal shape. Yes. Are you able to get the imagination, everyone? So then it is known as a V belt. If the cross section is something rectangular like this, then it is known as a flat belt. Understood the difference between these two? Okay. So first we will be solving the problems on flat belt. Again, after that, we'll be going for the V belt. Totally, there are two types of belt system, nothing else. Okay. In every type, suppose in case of a flat belt, there are two categories of the problems. Number one is just some parameters would be given. Some parameters you have to calculate by use of a data handbook. You are not specifically designing anything over there. Okay, it is just a parameter-based problems. Okay, for example, this particular problem, which is that you are not designing anything. He will not use the word design over there. You are not assuming anything. So such problems are just parameter-oriented problems. Just he will give some data. You have to use the formulas and you have to give the whatever which is asked. And second category of the problem is design-oriented problems. Design-oriented problems in the sense very limited data would be given. For example, design a flat belt drive to transmit a power of 30 kilowatts, which has a speed reduction ratio of 3. That's it. So all other data you have to assume suitably and design each and everything and even check for safety of that particular belt. So this is the design-oriented problems. Another one is parameter-oriented problems. Certain parameters would be given, certain parameters we have to calculate. For example, this. Shall we start? Okay. So two pulleys are there. One is 200 mm in diameter and the other one is 150 mm in diameter. So there is a larger pulley. I will just draw a larger one. And there is a smaller pulley like this. Okay. Now, how it is connected, that is also we have to see. So this connection, whatever you have seen, this is known as open belt connection. Okay. This is the open belt connection. There would be one more connection where you connect in this way. Okay. You connect a belt in this way. And this is known as cross belt connection. This is known as the cross belt connection. So what is the difference between this open belt and cross belt? Is in open belt what happens, in what direction the driver is rotating, in the same direction the driven also will rotate. Okay. So what happens in a cross belt is in what direction the driver is rotating, opposite to that particular direction the driven would rotate. Okay, you can have the small diagram in your notes so that you can have a brief idea about open and cross belt systems. Okay. Okay, done. Now, so two pulleys of 200 mm in diameter and other is 150 mm in diameter are connected by means of, he has clearly mentioned it as a cross belt drive. Okay, so keeping this, I would erase this. So this is a cross belt connection. Okay, just move. Okay, so this is a cross belt connection like this. Okay. So whatever the direction is there would be reversed on the other hand. So the diameter of the larger pulley is how much? So this is capital D, which is 200 mm, and diameter of the smaller pulley is small d. How much it has given? It is 150 mm. Okay, by means of a cross belt drive. And even he has given the center distance, which is capital C, which are 2 meters apart. So to find what we need to find, so to find length of the belt required. So length you have to find out. What is the length of the total belt? Length of the belt in the sense, what is the total length? Starting from here. Just observe this. Just observe this. Now what is the total length of this particular belt? All this length. How much is that particular length? You have to find out. Okay. Next, the lap angle between each pulley and the belt. So lap angle in the sense both he has asked. So even you have to calculate theta S and theta L. So when there is a cross belt drive, remember the theta S would be equal to theta L. When it is an open belt drive, it would be of a different value. It would be of a different value. When it is a cross belt drive, theta S would be equal to theta L. Since it is a new concept to you, I would just write in the red color. So theta S is equal to theta L. Why? Because that is questioned. And why? Because this is equal? Because this is a cross belt drive. Very good. Next one. If the larger pulley rotates at 300 RPM, larger pulley in the sense this particular thing, capital N, rotates at how much? He says 300 RPM. Okay. Find the power transmitted assuming the maximum tension in the belt is as 1 kilonewton. I told you the maximum tension, I would just write it as Tmax. Tmax is how much? 1 kilonewton here specified. Okay, maximum tension. And the coefficient of friction between the belt and the pulley is how much? 0.3. Even he has mentioned the coefficient of friction for us. It is 0.03. Okay, that's fine. What else? Anything else I have missed? Any parameter I did not write? Whether I have taken care of all the parameters which is mentioned in the problem as a given data? Yes. Shall we start the solution? Solution. Okay. Now, for this particular solution, the first one which is asked is the length of belt. Now, it's your task to refer the data handbook and give me certain formula through which, or certain hints through which I can calculate my length of the belt for the given belt arrangement. Just check the data handbook and give me the right equation number. Okay, 14.290 is the page number. Okay, I will just check. 290, so it's on the okay, so 289 and this is 290. Okay, so two equations are there. The first equation is for the open belt and second equation is for the cross belt. So which equation shall I use? The second equation, which is 14.2c. Very good. There are two parts of equation. One is this particular part, which is approximated to this particular equation. So which equation should I use? Should I use the first or should I use the second? The second one, right? Because I have all the data. I don't have theta value as of now. I did not calculate. So I'll be using this particular equation. Let me write that equation for you. Okay. So length of the belt is given by, it is given by pi by 2 plus capital D plus small d divided by 2c into capital D plus small d plus square root of 2c square minus capital D plus small d, its whole square. So this particular equation I have got from the equation number 14.2c from the page number 290. Now substituting everything in this, so it is pi by
4c square
plus ಏನಾಯ್ತು? What happened?
the equation 4c square alwa
4c square. Howd 4c square. So this is 4c square. Just check the equation now. Okay. Now it is 300 plus 150 divided by 2 times of. Remember, either you substitute in mm or you substitute in meters. Everything is should be of the same unit. Suppose if you are substituting in mm, all the things should be in mm. If you are substituting in meters, all the things should be in meters. Now I am substituting in mm. So C is 2 meters. So in mm it is 2000. Okay. So capital D is again 300 plus 150 plus square root of 4 times of C square, which is 2000, its whole square, minus 200 plus 150, its whole square. Please give me the length of the belt in mm.
Sir, capital is
Capital
D is 200, no, sir.
correct. So this is 300 alla 300 or 200
200.
correct undu sir
200 correct. No. 200. So illi kuda 200 alla 200. Anywhere else? Now we just check the value. So which one should I take? 4266 or 857? 4565 is one more answer. 3 different answers I have got. Why? What's the reason? Just check. Okay, it might be because of wrong substitution. 4580 4036. Why there is a difference, man? Why there is difference. 4016, 4025, 4082. Not even a single value of a Siemens. Why? Four, 565. Oh my God. 4730. What's happening?
Wrong again. Substitution. Whole multiply.
Okay, now, acha. Substitute it correctly. Okay, it's just check. It is 4c square or 4. It's just 4c square, not 4c whole square. Okay. Substitute it correctly and give me one value, guys. Which one should I take? Please give me that particular value. 4565 is correct. Okay, two people, Nitish and Sudhanshu, have given that. So on the trust of those two, so 4565.06. 8572, Amitun.
ಅಲ್ಲಿ ಸ್ಟಾರ್ಟಿಂಗ್ ಅಲ್ಲಿ 5/2 plus d plus d2c whole multiply by d plus d.
Correct. This is, just check the data handbook if we are wrong. Yes, it is whole multiplied by this thing. Very good, very good. So this is whole multiplied by this. Just check now. Same, huh? Whatever the answer which I have written on the screen, is it correct? So if you get the same value, just raise your hands. How many of you got the same value? 4565. Abhirami, good. Good. 4565. Okay, let us stick on to this. Next, what you have to find is, what you have to find? The next one, second one. Angle of contact. Angle of contact. So what? Just refer your data handbook and give me the equations for a cross belt drive to calculate the angle of contact. So it's in the first. So you can observe here. So for the cross belt drive, okay, for a cross belt drive, he has clearly indicated that you know, need not even remember it. So theta is equal to theta s, that is equal to theta L. So you can use either of these two equations, approximated one. So which one shall we use? The first one or second one? Okay. Pick this. Theta s is equals to theta L is equals to pi times of pi plus capital D plus small d divided by C. So that is equal to pi plus. Now remember, whatever the value you get, you will get it in radians. So 2000. So theta s is equal to theta L is equal to dash radians. So what is the value in radians? 3.31 radians. So if you want it in degrees, what do you have to do? Anyone? So this is in radians. No, if I want in degrees, what should I do?
Into pi by 180.
180 by pi. Okay, so 3.31 into 180 by pi. If you do, you will get the value in degrees. Okay, if you want, you can do it and keep it with you. And the last one which we are supposed to calculate is the third one, which is power. Now, please refer and give me certain equations through which I can calculate the power. In order to find the power, is there any equations in your data handbook? Please have a check and let me know. So this time I would help you because there are many equations to calculate the power. One, if the density of the belt is given, there is a certain formula. So the simplest of all is this particular thing: power is equals to T1 minus of T2 divided by 1000. We'll get it in directly kilowatts into V. So this is taken from equation number exactly 14.5a on the page number 291. So V you can calculate. V is equal to, so V is equals to pi dn divided by 60. That is equal to, so pi capital D is 0.3 in meters. I'm substituting it. So 300 is its speed divided by 60. So from this, what is the value of V in meters per second? .72 712 meters per second. Now, remember, I told you there is something called as TC, which is known as centrifugal tension. So this centrifugal tension has to be taken into account only when the velocity is greater than 10 meters per second. Okay, so when the velocity is greater than 10 meters per second, only then you have to consider the value of centrifugal tension. Okay, now what is the velocity in this particular problem? Whether it is greater than 10 meters per second or it is less than 10 meters per second.
200.
D is? How can I 300 and the karma? 200. The speed is 300, so it is 0.2. Is it same or it gonna change? 3.14. Okay. So it is 3.14. Now, whether this particular value, which is 3.14, is less than the 10 meters per second, it is more than 10 meters per second. Definitely it is less than 10 meters per second. That's why you have to write the sentence: since the value of V is less than 10 meters per second, the effect of centrifugal tension, which is T to the suffix T's, is neglected. Then the maximum tension he has given in the problem, isn't it? So T max is nothing but the maximum tension. So this maximum tension will always be the summation of T1 plus Tc. Since Tc is neglected, so what happens? Your T max would be equal to T1, correct? So T max, what is the value of given? Whatever, 1 kilonewton. So T1 is equal to 1 kilonewton. So from this, I can have T1 is equal to 1 kilonewton, or I can write it as 1000 newtons. Clear? Now, there is a famous equation. T1 divided by T2 is equal to e to the power of mu theta. So we have to remember this particular equation. So that I will change the color. Right. So you have to remember this. So this particular equation is known as the ratio of, this is popular equation, guys. Even you have learned this particular equation in your EME class also. Hope I am right. Remember, this was there in EME also. How many of you remember this equation that this was there in EME? Raise your hands. ಹಬ್ಬ 2 ವರ್ಷನ 3 ವರ್ಷನ ಆಯ್ತು, ಎಲ್ಲಿ ನೆನಪಿರುತ್ತೆ ಸರ್ ಅಲ್ಲ. This particular equation is known as ratio of belt tensions. Very popular equation. Even you have in your data handbook, I guess. I don't know. I did not search for it. Okay. Just search. If you have it, just give me the equation number. Even I can write it here. Okay. So from this, I can calculate the value of T2. So substituting T1, 1000 divided by T2, which I am supposed to calculate, e to the power of. So mu value is given as 0.3 into theta is 3.37 radians. Okay, 14.3 AL then already done. 14.3. So here you can find them directly. Very good, man. All the things are made simpler. So what I would do is, okay, so what is that equation number? 14.3a on the page number 290. 290. Then I would change this to black. Okay. Now, from this, what is the value of T2, guys? In newtons. 363 or 369? 370. It is just 1000 divided by e to the power of 0.3 into 3.37. E to the power antandre you will have that value of e. So alpha e. So this is the value 2.71. Okay, if you do not get it, you can find it here. Alpha e, alpha exponential. Here at the bottom line there is the value of e. 363.8. Okay. Now, since everything is calculated, now calculate your power. The power is given by T1 minus of T2 divided by 1000. Just you are dividing it by 1000 to get it in kilowatts directly. So T1 is how much? T1 is 1000. Tension on the tight side. T2 is 363.8 divided by 1000 into the value of velocity. Velocity is 3.14. So 3.14. Now, what is the power in kilowatts directly? Yes, give me the value of power.
1.997.
Okay, so 1.997. So approximately I can let it as 2 kilowatts of power. Okay. So there ends your problem. Any doubts in this particular problem, guys?
ಸರ್ ಅದು ಥೀಟಾ ರೇಡಿಯನ್ ಅಲ್ಲಿ ತಗೊಳ್ಲಿಕ್ಕ ಡಿಗ್ರಿಯಲ್ಲಿ?
Radian. Whenever you're substituting in e to the power of mu theta, it should be substituted in radians. So I would just write a note also here if you want. Okay. So this particular value should be substituted in radians. Okay. Any other doubts? No? Okay. So then mark your attendance in the Google Sheet. You can leave the class. We will meet in the tomorrow's class. We'll discuss one more problem on this. Okay.
Sir, Amir sir.
Amir, ಹೇಳು.
Sir, attendance.
ಹಾಕ್ಲಿಕ್ಕೆ ಆಗ್ತಾ ಇಲ್ವಾ ನಿಂಗೆ?
It's not loading, sir. Actually, I've been refreshing it so many times.